Hey everybody, Dr. Heldman here. Welcome back to Tech Talk Education. Sorry I've been gone for a week. I've been really busy on a big project that I'm going to do a movie for next week. And let's get started. So what I want to talk about today is there is a difference in the way that we talk about numbers when we're dealing with computer storage and computer speed, the speed at which a computer can move. And it's really interesting. I just happened to run across this when I was doing some research for another project, and I thought you'd like to know about it. So this shouldn't be a real long movie, but it should be pretty informational. Let's get started. Okay, so what we're doing is we're describing the amount of space that's, say, on a hard drive or on computer RAM, and I think that we can use this for the meaning of speed as well. We'll talk about that in a minute. But there are two ways of describing these things. So there's the basic way, which is called the SI way, and it is rendered in metric numbers. So we're talking about base 10. Everything is a multiple of 10. But there's another system called IEC, and it uses base 2. So it's binary, and it's a little bit more accurate, and it's also rendered with a little bit different nomenclature, so we want you to know about both of those. Now let me go ahead and advance this slide here. We've got the metric SI here, and the thing that you want to know about is there are all kinds of standards bodies all over the world that make decisions about how things should be, what the quantities should be, how they should be handled, this kind of thing. And so in the United States, we have a standards organization called NIST. It's the National Institute of Standards, and it is in partnership with what is called the International Standards Organization, ISO. So these two play together, and they establish standards across the globe. So these standards mean something. Well, they have created an international system of units. It is called SI, and it's based on the metric system. And the important thing here is that to realize that it is base 10. And I've provided the website for you here so you can go look at this, get a little more information. It's actually a pretty big endeavor here. But also we have the International Electrotechnical Commission. It's called the IEC, and they are doing something different. So they're denoting a nomenclature that we use when we're talking about computer storage, but they use a binary version of this, so it's a lot more accurate, and this is called IEC. So the next thing I want to do is I want to go into Excel. I'm going to show you Excel, and we can calculate these things for ourselves so you can see how they work. All right, so here we are in Excel, and I've got a little chart made here, and you guys are probably very familiar with the concept of a kilobyte, so maybe not. When I query my students about what kilo means, they have no idea because this is an older term. Kilo is metric. It means 1,000. Mega means million. Giga means billion. Tera means trillion. Peta means 1,000 trillion. Exa means 1,000 peta. Zeta means 1,000 exa. And yada means 1,000 zeta. So those are the units that we're using for storage. And they're denoted by KB, MB, GB, TB, PB, and so forth. You guys have seen this. Now, it is important that I want to point out to you, when you see a capital B, not a lowercase b, but a capital B, that means bytes. There are 8 bits to a byte. So we are not talking about bits here. We are talking about bytes. And so KB, capital B, means kilobytes or 1,000 bytes. And these are common measurements of storage, like in hard drives or in RAM, things like that. Now we can figure what that equivalent is here because we remember that we're using a base 2 system. So here's how a base 10 system. Base 2 is for binary, so we'll get to that in just a minute. To calculate this, you can just say, well, this is going to be equal to base 10. I'm going to put in the caret key, so that's an uppercase 6. And this is a universal symbol for a raised to the power. Caret can also be used to symbolize the control key in certain settings. In this case, we're going to raise it to the 3rd power, like so. So we've got that. Now we can keep going down, and instead of third, it's going to go in order. So 3, 6, 9, and so forth. So let's make this equals 10 to the 6th, like so. And you can see how it's widening out these numbers. I'm going to go ahead and fill in all the rest of the columns and show you what this looks like. Okay, I'm all done. I've widened this out a little bit so that you can see the gradation here. 3, 6, 9, 12, 15, 18. And what this means is that, like here, when we've got gigabytes, this is a 10, a 1 followed by 9 zeros. So let's see if that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So this is a 1 followed by 9 zeros. And this is called scientific notation. I don't know if you've messed around with this or not. But what's happening here is when we have very, very large numbers like this, Excel is displaying this using scientific notation, because honestly it would be very difficult for you to read it anyway. Another thing that you could do is you could come in here and put commas in, and the way that you do that is you click a cell and then you click this comma here, and it will render it with the commas right there, so it looks a little bit easier. And we can bring this in. We don't want to see the decimals here, so I'll bring those decimals in like that right there. And now we have gigabytes. And you could rinse and repeat, and you could do the same thing here and get rid of the decimals, and you could do the same thing here, get rid of the decimals. Let me finish up the table for you so you can see it. And I think you get the idea. It's going to get very, very large very rapidly. So these are quite huge numbers. Now these are base 10 numbers. The reason we call them base 10 is because if you look up here in the bar here, it says 10 raised to the 21st power. These are all in base 10. Now, we'll turn our attention to binary, which is IEC. These are base 2, and they have a very unusual name. And as I said in the introduction to this movie, I ran across this. I saw this KIB, and I'm like, what on earth is KIB? I thought that it was just a European way of saying kilobytes, but it is not. When you see cap K, lower I, cap B, what you're looking at is what is called a kilobyte. And this is the IEC rendition of the number versus the metric version of the number. So it's, in the metric, it's base 10, and in the IEC version, it is base 2. So let's go ahead and see what this looks like. I'm going to go squish this in a little bit so it's a little bit easier to see. Maybe move it out just a little bit here. Okay, so kilobyte. So this is a kilobyte. So we do the same thing, but we say now we're going to start in powers of 10. So we say 2 raised to the 10, like this. And you're going to get a little bit different number. Now, why is this way? Well, because you remember that when we're dealing with any sort of numbers like this, bits means that it's either on or off. So that's where we get the 1, the 0 or the 1 from. There's only 2 possibilities, on or off, for each bit. So if we have a kilobyte, we can have the potential for 1024 or 2 to the 10th possible numbers. And so we render this as 1024, and you can see that it's a little more accurate than 1000. So we would generically say, this is back in the day, I remember talking about hard drives that were rated in kilobyte storage. And so it's a little, what we've done is we've taken a very accurate number and just boiled it down to metric so it's easy for us. Oh, this is in terms of 1000, this is 10, 20, 30, so forth. Now, that's what binary is doing. So we can actually take and do a couple of more of these, and I'll fill in the chart for you so you can see this. Okay, I've got the chart finished now. And now what I'm going to do is I'm going to squish this column way down. I'm just going to hide it from view a little bit so that we can look at how big these numbers are. I'll grab this column here. I'll go ahead and apply the comma thing to it. I'll drag this out of the way so we can see it. And then I will get rid of these percent sign, or the decimal part. There we go. Now look, here's the thing. When you're looking at this and it is in this fashion here, we're looking at it in IEC fashion, this is a dramatically bigger number than this number over here. Let me show you this number real quick so we can see it. There we go, and I will make this happen this way as well. And I'll try and get the two put together. I'm going to pause the movie and put the two columns together. Okay, so now what I've done is gotten rid of the nomenclature columns here. We're just looking at the metric value, which is SI in bytes, and we're looking at the binary value, which is IEC. And then you can see that this is a dramatically larger number, so it's much more accurate. And that's the point. When we're doing these binary measurements like IEC, what we have is we have a much more accurate number than we have when we're simply rounding here. And all this represents is, oh, we're rounding everything to like a base 10, and this is accurate to base 2. So that's the difference between the two. And then let me unhide that one column because I want you to see. Let me see if I can right click here and say unhide and bring this out a little ways. I want you to see these terms. I'll move this in a little ways here. So the terms are weird. So you've got kilobyte, megabyte, gigabyte, terabyte, petabyte, exabyte, which is very, oh, and I misspelled that, zettabyte, and yottabyte. And these should all say byte, and I don't know why they came across this way. Let me fix that. I did a block copy on that, and when I copied that, Excel came over and it said, oh, you know what, this is, it put this YI on the end of it. That's why it looked all goofed up. Anyway, we have petabyte, exabyte, zettabyte, and yottabyte. So those are weird names, and the main idea here, the big idea, is that these are much, much more granular. These numbers are much more accurate than the numbers that we're using over here for decimal, base 10. Now there's one other thing I want to say, and that is when we render a speed, oftentimes, like if I'm using Grok, for example, Grok AI, it's going to show up in terabits per second. Now when you see a little b like that, it is not talking about bytes like here. We've got terabyte or terabyte. That is not what we're talking about here. So it's not a measurement of 8-bit bytes. It's a measurement of a single bit, and so we lowercase the b. So you're going to see network speeds rendered as gigabits per second rather than gigabytes per second. You've got to train yourself to look for the capital B, and if it's capital B, you know it's talking about bytes, and if it's lowercase b, it's talking about bits. And when we're generally expressing terms of speed, we express it in bits, and it's always in bits per second, or it could be even faster. Or if we're expressing it in terms of storage, it's going to be in terms of bytes. I hope this is helpful. It's very odd, and I thought I wanted you to see it so that you can look for this. And if you go out and you do a little bit of looking on the web, you'll find a lot of information on SI versus IEC numbering systems. So thank you for listening, and I will talk to you in the next movie.